Hello everyone. In this video we'll learn what is Secure Enclave and how can we leverage that as a developer. Usually save data persistently in the app using user defaults, keychain, SQLite or core data. For example, to save session of logged in user, we save username and password. But this process puts our data at high security risk. It's always recommended to store sensitive data in encrypted format. But again, it's a challenge to secure keys used in encryption and decryption. Well, here Secure Enclaves comes in the role. A Secure Enclave is a hardware-based key manager that is isolated from the main processor to provide an extra layer of security. Using Secure Enclave, we can create the key, securely store the key and perform operations with that key. This makes it difficult for the key to be compromised. Here we are using Secure Enclave in encryption and decryption. So let's have a look. First of all, I'll create an Xcode project here. For that, I'll launch the Xcode and we'll click upon the create a new Xcode project. Yeah, so after that I'm selecting single view application as type of my project and choosing the Objective-C as language. I'm naming it this project as Secure Enclave demo, and let's create it by clicking upon next on desktop. Yeah, so it has been created, and in this project now I'm going to create a wrapper, naming it as so for that I'll right click upon the project folder and we'll click upon new file. We'll choose Cocoa Touch class, and yeah, the class will be type of NS object, will be subclass of NS object, and naming it as sec enclave wrapper. This wrapper is going to use Secure Enclave to store the keys, generate the key and perform operations with that key like encryption and decryption. And here I am declaring functions to encrypt the data and decrypt data from which can be used in another view controller or another class to get data in encrypted format to save in the user default here in the example, and to get uh, encrypted data back in the decrypted format in the original format. So here I'm declaring the function. Let's say it is returning ns data object, and naming it as encrypted data. It will receive argument as ns data again. So we can, if we are having any array or dictionary or string or any kind of data to store anywhere in encrypted format, we can pass here that data, that converted data. Like, we can convert the string or JSON or array into the data first, and then we can call this method to encrypt our receiving data. So yeah, this is also returning, and this is accepting the data as parameter here. And similarly, we'll declare one more function which is going to decrypt encrypted data. So this is also going to return the NS data only, and the name will be like decrypt data, and receiving it will receive the encrypted data. Yeah, let's name it as data only for the time being. Yeah, and in the .m now I'll define some macros like new cf dict, type of cf, dictionary, create, mutable, case, cf allocate, default, and 0, and object type of case cf type, dictionary, callbacks, and KCF type dictionary value callback. Yeah, callbacks. That's it. And also we'll define some more macros. Here, these macros are going to use in referring the private key and public key, whether it is in the storing time or getting time of the keys from the keychain stored. So let's name it as k private key name, and let's take the value as com.secure enclave dot private, anything it could be. So I'm taking it as here like this, and then one more for public key, for referring public key, and here the value can be like public. So yeah, these are the macros defined. Now we will create some static variables for again referring, for again going to be used in the referring the keys, private key and public key. Let's name it as sec key ref, and the variable will be, name will be public key ref, and similarly for private key the type will be sec key ref only, and the name I'm taking as private key ref. Fine. Alright, after that I'll just create again here in this an instance type initializer, say, which would return the instance of this class. So it's here I'm going to follow the convention only. Let's say self equal to super init, basic thing, and then here one important step is going to come now. Like we can check for the upcoming method, like look up, let's say look up public key ref. This is the method I'm going to define later, but this will return, this will search public key in the keychain, and if it is sustained in the keychain, then it will return the public key. So we can check whether the public key is already saved here in this, for this project, and then we'll check either the public key or the private key is saved or not, and can we get returned with that key. So here I'm naming it as lookup private key ref. Yeah, so if any of the key exists, then this method will not get called, and if both of those are both of these keys will be non-existent, then we'll call this method, following method, self generate passcode key pair. Do not worry about these methods or about these errors, because these methods I'm going to define now. So let's just complete this init method first. Return self from this. Yeah, so this is the initializer method, which this project is going to throw error this time, but do not worry. Now we'll define these methods one by one. Very firstly, let's define this lookup public key reference method, and this is returning the key, public key, as type of sec key ref, and the name is, again, I'm copying it from here only because I've already written it. So yeah, in this definition we'll just use a fixed structured pattern for the key
to get from the keychain. So let's say OS status sanity check equal to no error, and then we'll define an as data. Let's name it as tag. Then ID key class. Okay, and now here in this we'll check for the public key reference. If it is not equal to null. If it is already there, then if it already exists in the memory, then return it. Else we are going to create one from these references we defined in the macro. So k public key name data using encoding ANSUTF8, and the key class equal to let's say this, type as ID, and the name, the expression will be for ksec attribute key class public, yeah. So yeah, that's it for defining the key class variable. And now we'll just query from the keychain for the same, and it will return us the public key. So let's define a dictionary with the properties as these will be the fixed variables we are using in the dictionary. You can use it as it is in your project. There's ID, ksec. These are the properties of ksec secure class security framework, and these are, and many of the properties from this wrapper is only will work only for the iOS 10 or above. So you can use this project for in the project as taking minimum deployment target as iOS 10, because Secure Enclave ID token will see in the future a property which is itself working only in the iOS 9. So yeah, you can use this project in this wrapper in the iOS 10 or above projects. So yeah, let's come to the point where we have left it. Yeah, so keys a class, and the type, the value will be, these are the classes, these are the keys which are the defined keys in the security framework. So value will be, again we have to transform this with Bridge ID, and here we'll take the ksec class key as a value, right? Then the other value property of the dictionary we'll define similarly. Let's copy it. So yeah, this is the property, this is the key, and now I'm going to define another key as attribute key type. Yeah, so key type will be ksec attribute key type EC. This is the algorithm we are going to use as EC. It can be RSA or something else also, but this time I'm going to use EC here. And then we'll use the ksec tag, application tag key, and we'll save the value as tag what we have defined here in this before. Yeah, here. And then we'll define another property as ksec attribute key class. I sing it here. Key class. Yeah, we'll define the value as key class, After that, again one more will be here, like ksec attribute, ksec return reference. These are going, this is the structure of the key we are storing, so that we can while we are fetching the key, we can query the secure, query the keychain for the same structure of the key. Yeah, so here we are saving the value as kcf boolean true, and yeah, that's it. It is, this dictionary is being defined. Now we'll define a variable as sec item copy match. This will match this will match the dictionary in the keychain for the same value and key pair, so that we can get the public key if it is stored in the keychain already. Yeah, so here we'll define another dictionary, which is bridge cf dictionary reference. The expression we'll take as query dictionary, which we have defined already, and the cf return type will be cf type reference. Here we'll say public key ref, in which we want our public key to be stored, I mean public key reference to be stored. So yeah, this is done. Now we'll check if sanity check is not equal to r success. These are the defined sec framework enums as success. Then something we can do, if it is not the success, we can say we can log here for the failure, like error while retrieving the public key from the server. Yeah, so if it is the key, if it is the error, we'll show it here in this block, else we'll return the key public key reference we have stored, we have taken here. Now we are going to create another method similarly, like we have just looked up for the public key. We are now going to take we are going to look for the private key similarly in the same way, and this method is going to return the secref again, reference of the private key from after lookup. Let's name it as lookup private key ref, which is again similarly will create the query or the dictionary, and on behalf of that it will match the keychain for this key, and then after getting it will save into this reference variable. So yeah, let's say cf mutable dictionary reference, naming it as get private key ref, and the value is new dict. We have already defined it in the beginning, and then we'll say again cf dictionary set value, cf dictionary set value. Yeah, this is here, it will take the dictionary name, so get private key ref, and the key is ksec class but we have already defined for the public key also, so we are just going to use the same keys and same values, I mean almost similar, and yeah, the same pattern. So let's follow ksec class key ksec class is a key, and the value of it will be ksec class key. ksec class key. Somewhat it is very confusing. The names are, but yeah, these are the fixed names and very handy also. So I'm just copying it here for the properties. So yeah, the key, next key will be ksec attribute keys class, and the class will be private. ksec class private, then ksec attribute class key attribute label, ksec attribute label attribute label, and it could be the name of the key, any name. So we have already defined it as macro. K private key name, private key name, then ksec return reference. ksec return reference, it will return the value yes. So ksf boolean, kcf boolean true, then yeah, so the dictionary has been defined. Now we'll again OS status sanity check again. We'll match this dictionary into the keychain. We'll have here the cf type ref pointer, and the variable will be private key ref. Yeah, so in this the private key will be stored if has got. Then the status we'll check for the success like we have done in the previous method. If the status equal to our success, as a item not found, let's say. If it's not found, then return nil as private key reference. Otherwise, return the private key reference stored just now. So nextly, we'll create a method to generate the private key and public key as a pair in the secure enclave. Now the secure enclave will actually come here into the role and will store, it will create the key inside it, and it will store the private key inside it, so that it will be not, I mean, there will be so much less chances to tamper this in case. So yeah, the naming as the key pair which we have already used initially, so I'm just naming the same as the same. So yeah, here we'll define ce error ref first of all, cf error equal to null, then sec attribute, sec access control ref, sec object, and define it as sec access control create with flags. Yeah, here we'll see kcf yeah, so the property will be, we are going to use will be like kcf allocate default. We can see many properties, and we can use any of those according to our need, but default is the basic and which we are using here. Then next is ksec attribute accessible yeah, so accessible, there are so many accessible properties which has been deprecated also initially, some older properties. So here now we are going to use unlock this device only, and which means like the keychain will be accessible after first unlock, after resetting the device, and in this device only. So we can use any of those accessible properties according to our need, according to the security concern. And then the next property is the flag. For the flag, using as ksec access control private key uses, so that private key will be used in the methods of signing and verifying sign blocks. So yeah, and after that we'll just send the error variable we have created here in the beginning of this method. Now again we'll check for the error, upcoming error status. If error not equal to error success, error success, then we can print for the indications like generate time we are getting this error code. Yeah, and then after this, as we have defined the dictionary, we can pass it to another method which we are going to define now later. I'm just calling it here as generate key pair with access control object. Yeah, and here I'm going to pass the sec object, and this method now we'll define here. This will return the boolean variable, and the name is at this, and it is receiving sec access control ref. Yeah, let's name it as sec object only, or say access control ref. Yeah, so here now we'll do cf mutable dictionary ref. We are creating dictionary of private key info, naming it as ss control dict, and defining it as new cf dict, already defined as in the macro property of the structure of this dictionary. Okay, so now this is important step to create the to generate the private key and public key correspondingly. So here we are going to check for the simulator. As the following code will not work on the simulator, we have to use the iPhone only. So we can check secure enclave task in iPhone only. So #f not target iPhone simulator. Then if it is not the simulator, then we'll define cf dictionary add value in this dictionary in this dictionary with the property as basic attribute access control access control ref. This is going to be used for the iPhone only, the access control, and then again we'll add similarly properties into the dictionary out of this. It's similar to check block. Yeah, so here we'll do now as access control dict case attribute is permanent. Attribute is permanent. The value will be, let's say, case if cf boolean true, and similarly we'll define dictionary for more properties so that we can add at the time of saving the key into the keychain, and so that it can be used while accessing or while looking up for the key in the keychain with the same dictionary, with the same values of the dictionary. Yeah, so this is the property as permanent, and then we'll define as ksec label, as we have already seen in the above methods that we have used these properties to while fetching, while matching the key in the keychain. So the label, let's say for the private, it will be private key name, and then we will create the dictionary which actually save key into the keychain now as cf mutable dictionary reference generate pair ref is the name of this dictionary, and it will be destructor of it will be like new cf dict, and again if it's not the target as iPhone simulator, that means if it is the device only, then this code should work. Yeah, it will contain access control again. It will contain the sec attribute token ID, which will contain the value as secure enclave token ID, and this property will work only on iOS 9 or above, so take care of that. Dictionary add value in the generate pair ref as the key sec attribute token ID as key sec attribute token ID secure enclave. So this property into the dictionary will going to tell to the system that we want secure enclave to use for the purpose of generating keys and saving those keys into the secure enclave. So this time the private key which is going to be generated only will be saved and created by using secure enclave, and this will work only in the iPhone real device, not in the simulator. It will work, but it will not crash or it will not give the error because we have used this code block, check block. So yeah, we'll further add some more properties in this dictionary as save dictionary add value. We'll pass the dictionary variable here, and then ksec attribute key type as the property key name, and the value will be ksec attribute key type ec. ec is the algo which we are using here. Again we'll add some more properties like size in bits, keysec attribute key size in bits, which can be anything. Like here we are using 256 constant void and a pointer. The expression in the expression we'll take the number and as number object with 256 bytes. And then again another property will be keysec private key attributes, in which we'll save the dictionary, access control dictionary, which we have defined only for the only for the real device. This property is also not going to use in the simulators case. So yeah, this is the dictionary created, and now again we'll check for the OS status sanity check, like status, and we'll generate the pair here, sec key generate the pair of private and public key with these references, generate pair reference, and return it in the public key ref and private key ref correspondence with the in correspondence with the public key and private key. It will be stored accordingly into the variables. So yeah, this is done, and now we'll check again for the status. Like if the status is not equal to R6 success, then we can ls log for something like error while generating key pair, right? And we can show the error code also, like status we can show as it is OS status from the secure framework, so we can use it, we can brace it again, we can convert the type of this, we can cast it as into the int and print the code, and let's return no also from here, as this is returning the boolean. This method is returning boolean. After this, if the success is the status, like we have got the status of success, like we have successfully created the private and public key to the secure enclave. So after this, the private key will be automatically stored very securely into the secure enclave, but the public key we have to store separately in keychain, and later on we can get it from the keychain, and corresponding private key also can be got from the keychain, and then can be used in encryption and decryption methods according to our use. So save public key from ref. Here I'm calling this method, and this I'm going to define late now. Yet now we have defined some methods like lookup public key, lookup private key, encrypt data, decrypt data, and generate, and for generating the key pair yet now. So here we are passing the public key reference into this and return yes. If it is not no, then it's yes. If it is success, then it's yes. So now we'll define let's define this method also now to save public key in the keychain. As it is not going to be saved automatically, we have to save, but the private key we do not need to save in the public key explicitly, keychain explicitly, because it is going to be stored in the secure enclave securely. So yeah, we need not to worry about that. Here we are naming it as public key ref this variable. Yeah, and here we are going to save like OS status sanity check equal to no error. Let's define initially it as this. Then NS data as variable tag we'll take ID key class. Yeah, we'll define tag as with k public key name label and data using encoding NS UTF 8 string. Then key class would be like typecasting into the bridge ID to save in the sec dictionary. We'll convert it here like this, and the property will be ksec attribute class public and as dictionary pointer save dictionary equal to dictionary. We are going to define with so many keys and properties and the value of those keys. We'll convert the key. We'll define as bridge ID ksec class and ksec class, and the value will be bridge ID as ksec class key. And yeah, so this is the first property. I'm going to copy and paste here for more properties. So another one will be ksec class, ksec attribute key type. The value of it will be ksec attribute ec. Here we are going to use, here we are using ec only throughout the project. So let's take this here, ksec application attribute application tag Here we are passing the data value of public key name label as tag and ksec attribute key class attribute key class, value of it will be key class. Then ksec value data. Here in this we are saving the data of the key, actual public key reference data. So we'll bridge it like bridged NS data pointer of sec key copy external representation of public key reference. So this is the data representation of public key reference, and here we can send the nil into the error parameter. Yeah, this is done. Now again ksec attribute size, key size, or say size in the bits, ksec key size in the bits, and the size as we have already used NS number within number with integer 256 we will use here, and similarly we'll use for some more properties. We can add those properties, these are optional, but I'm here using as generic, so I'm using so many properties this time. Now another property is like ksec attribute effective size, and which is again 256. Then ksec attribute can derive, and we'll send here the bridge id expression will be kcf boolean false. Then ksec attribute can encrypt, so yeah, it can encrypt as this is the public key. This can encrypt. So it will be true. Then can it decrypt? Also, obviously not. The private key can decrypt and public key can only encrypt. So this should be false. Then we can say can verify, as secure enclave can be used for verifying the signature and signature and signing a block. So this time using can verify, yeah, it can be used to verify also. Then can sign, so no, it is not going to be used for sign. So false. Then can we unwrap and wrap by it? Wrap and unwrap. So can it unwrap and wrap? Can wrap? Yeah, it can wrap too. And it cannot unwrap. Either it can wrap or either it can unwrap. So as it is wrapping, as it is encrypting, it cannot decrypt, it cannot encrypt, unwrap. The only private key can do that. So sorry, unwrap should be false. Yeah, we are done with our dictionary, and this is dictionary's closing braces. So yeah, this is done. Now again sanity check, and we are adding this dictionary into the keychain this time. So check item add, bridge id, uh, bridge CF dictionary ref, or we can use id also, not show save dict, and then cf type ref pointer and pointer of reference of public key reference. So we are saving public key reference like this in keychain. Then if sanity check not equal to error success, we can log for indication of that, like error while saving, error when trying to save public key in keychain. We can show the error code also in the logs. I'm skipping it for now, and then return the saved public key reference. So yeah, we are done with these methods for with the looking up public key, private key, generating the public key, private key pair, and saving the public key, as it is not going to be saved automatically in the secure enclave. So we'll save it in the keychain for the users for accessing again. So now we'll define two more methods like encrypt data and decrypt data. And so yeah, as we have already declared it in the .h file, that it will return the NS data, encrypt data, and it will receive also a data NS data of the of your string or array or JSON or any kind of data. You have to convert it into the NS data before encrypting and getting encrypted format of your data. So if in this method we'll write the definition of it, like if data and data's length. If data is present, then what will we do? We'll use our private key, public key to encrypt the normal data. CF data reference cipher sec key create. See, you can see the methods for creating signature and wrapping and signing and verifying the signing block. So we can do so many things with the secure enclave, but right now we are using and it for encryption and decryption. So let's use this method, encrypted data, and here we'll pass public key reference for encrypting. Algo we'll use EC like ksec. So many algos are there, but we have to use one throughout. So encryption standard 963. There are so many uses of these different algos, different meanings of these algos. So you can read it into the reference given in the video's description. So let's say key 963 SHA 256 ES AES AES GCM. Then we'll use CF data ref of CF data ref of the data taken in the argument and passing the nil as error. And yeah, so this is the encryption method of the security framework, of the secure enclave framework. Then we'll return this encrypted data in NS data format. So NS data pointer, as it is returning the CF data, we'll convert it into NS data and then we'll return. And in the else, as if it is not having the data, the original data to be encrypted, then it will return the nil only. And like NS data decrypt decrypt data, which is also receiving NS data pointer data. We'll check here for the data and data's length. If it is so, what will we do? We'll use the cf data ref explain data and we'll call sec key create decrypted data using private key reference. In the algo we'll use again the above algo used in the encryption. So yeah, this is the algo and the data reference will be like cf data ref data as an argument, and in the error we are using nil for now. So this is the decrypted value in the plain data variable. We'll return this as by after converting into the NS data rich id rich NS data pointer plain data, and otherwise in the else block, I mean if the data is not presented, the encrypted data is not there, then we'll not decrypt it, we cannot decrypt and we just return the nil. So yeah, this is the encryption and decryption method also. Now let's come to the viewcontroller.m and here we'll import this wrapper of ours as secure enclave wrapper, and in this view.load, we'll just let's suppose we are having a string as ns string str data to save, and in this we are having as example data to save, which we are going to encrypt and save into the user default. So we'll firstly create the secure enclave wrappers instance sec enclave secure enclave wrapper lock in it, which is not having any property to initialize, but yeah, we are having some functions like encrypt and decrypt to be used in other classes. Here we are going to use those only with this normal string, original string. So first of all we'll use it as secure enclave encrypt data. We are having a string as str data to save, which we'll convert into the data using a string encoding. String is encoding UTF-8. This is encrypted data. We are saving in the, let's say, NS data, any variable like str encrypted data. Then sorry, as this is the data only, we can change it into the string and we can print, but as it is encrypted it will not be, it will be undefined, like it will be non-readable, or say if it can be nil also, so it's just useless. So we are just keeping the data in NS data, and after this what will we do, we'll again use Secure Enclave instance or Secure Enclave class to decrypt our data, our this converted encrypted data. We'll pass here encrypted data, and this will return the decrypted data here. We'll save it in the decrypted data, and when we'll convert this NS string lock in it with data, then we'll convert this decrypted data into the string using NS string UTF-8 string encoding. Yes, encoding UTF-8. Then we'll get a string NS string decrypted. So we can print it now. This decrypted string we can print. And let's see what will be the result. So there are so many properties of secure and secure security framework which we have used some of those, and in the description of the video I will share the links for the properties specifications, and then also I'm again sharing it with you that you can use Secure Enclave only on iOS 9 or above, but this wrapper could be used only on iOS 10 or above, because so many properties are there which are going to work upon iOS 10 or above, and this is, I guess, so fine, as Secure Enclave is the demanding thing security wise, so this is a good thing. And so in the console we can see this is the string. So we have just printed here decrypted data, so we have to print a string of the decrypted data. So yeah, we can use Secure Enclave for many purposes, and if you want to use, if your project is like for having the minimum deployment target is less than 10, then you can use another thing for saving or for encrypting data which might be less secure than Secure Enclave, but for less versions you can use that, and then condition wise you can use Secure Enclave or this wrapper on iOS 10 or above. So yeah, we can see in the console that we have gotten this string of ours as it is, as the original string after encryption and decryption by this Secure Enclave. So yeah, we can do this by we can do this for signing also, for verifying the sign signature, and for encryption and decryption. And with the properties we can go through with the descriptions, documentations, and yeah, it would be very easy and very helping once we implement it in our app, in our daily uses. So yeah, that's it. I hope this video was helpful. If you really like the video, please press the like button. If you have any query, feel free to ask in comment section.